3:45, and I think we'll get started. So welcome, everybody. My name is Tim Chihan. I'm the Chief Architect of Commercial Civil Space at Lockheed Martin. And I've been really looking forward to this panel, which is called Trades in Space, a discussion of the need for skilled workers to prepare for Mars. And we've got a great panel here today. And today we're also kicking off a program at Explore Mars that's going to highlight, promote, and support the role of skilled workers in space exploration. And there's a lot of activity going on right now in space exploration. The Artemis program, the return to the moon, which is all a great dry run, of course, for going to Mars. But we're seeing a need for skilled workers to actually touch the hardware, build the systems that are going to go to the moon and Mars. There's even a White House initiative that was announced in September. There's a coalition of space companies working together and with academia to increase the capability to meet the demand for a skilled technical workforce. And so, and at Lockheed Martin, on the Space Coast, we've been working with both a high school program and a college program. So a high school program to learn how to be an aviation technician, a college program called Space Tech at Eastern Florida State College, and we're seeing results. We're pulling that talent to build things like Orion. I'm pretty excited about that. So let me introduce the panel real quick, and then we'll go through and they'll introduce themselves in more detail and what they do and what the background is. So first we've got Mark Aldaba from Aerojet Rocketdyne, and he's the senior lead manufacturing engineer. We got Dan Zabata from Jacobs. He is a crawler transporter engineer and driver. That's pretty cool. We've got Rebecca Tolatovich from ASRC, and she is the Orion Artemis 3 and 4 mechanical assembly technician. And then at the end there is Jason Dickerson from NASA. So he's an aerospace engineer and transportation engineer working on the Pegasus barge systems. So we're gonna understand these folks' background, get their perspectives on the challenges and opportunities ahead. I have some questions, there'll be an audience questions as well. And I really, before we get started, I really want to stress the importance of the folks that actually build and do and operate. I had quite an adventure getting here today where my first plane got up to altitude and started losing pressure out the co-pilot's window. And so, and the oxygen things didn't come down, so it was fine. But we landed back in Denver, and the first people on the plane were the mechanical technicians coming in to check that, and it was clear that the gate agents were working to get us our next flight, and it was really impressive to watch that workforce spring into action. And that was just one tiny little flight from Denver to Washington. Imagine going to Mars. So let's get started. So Mark, why don't you tell us what you do and what excites you?
Yeah, thanks, Tim. It's great to be here. My name is Mark Aldaba. I'm with Aerojet Rocketdyne. Right after high school, I really didn't have any clear direction in where I wanted to go. But what I did know is that I loved working on cars. And I loved working with my hands and building things and just getting dirty in the garage. So after high school, I went to a vocational school and I took some welding classes. And I started working as a fabricator for several smaller shops, working on motorcycles and on cars. And eventually, in 2007, I was hired on at Aerojet Rocketdyne. There I was hired as a metal fitting mechanic, and I worked on engines like the RS-68, the Space Shuttle main engine, J2X. I did a lot of hands-on work, everything from bending the material, cutting, shaping, and fitting any metallic parts on the engine. That was my job. Then in 2009, as Shuttle was winding down, I got laid off. And you know what? Working at at Aerojet Rocketdyne for those 2 years gave me a lot of experience. And that experience made it really easy for me to find another job right after. And within a few weeks, I got picked up at SpaceX. I worked at SpaceX as an assembly technician. Was there for a short period of time, about 2 months. And then I had a knock on the door, and it was Boeing. So Boeing Space and Satellite Systems in El Segundo, they called me. And I took a job over there. I worked there for a year and a half as an equipment rigger. And we were in charge of moving everything from ground support equipment to entire spacecraft. I was part of that team. And then in 2011, I got recalled back to work at AR to do my old job. So now I'm back at AR. I'm doing the same thing that I love doing. And there was another opportunity to move into a different job position. So I was the first one to raise my hand. And so now I'm working on in the machine shop. And you could see in the slide, that's actually the MMRTG, the Mars Mission Radioisotopic Thermoelectric Generator. Say that 5 times really fast. I worked on programs like that. And then in 2020, now I have all this experience working in different sectors and different parts of the shop. I was given the opportunity to become a manufacturing engineer. And my duties as a manufacturing engineer is that I work with the designers, the stress engineers, a huge team to formulate a plan and write the actual work instructions to how to build the RS-25 nozzle, which is what you see over there. And earlier this year, I was promoted to the lead manufacturing engineer for the RS-25 nozzle team, which in my opinion is the most iconic part of the engine. And yeah, that's my background.
Thanks, Mark. That's great. Dan.
How's it going, everybody? My name is Daniel Zapata. I am a crawler systems electrical engineer. And is the next slide going to show up with my stuff on there? Oh, there I am. Okay. So a little bit about myself. I grew up in Florida, born and raised. I'm Puerto Rican. I have Puerto Rican parents. I like to call myself Floricua, which is a Floridian Boricua. I graduated from the University of Central Florida with a degree, Bachelor's of Science in Electrical Engineering. And since 2017, I've been working with Jacobs at the Kennedy Space Center under the Exploration Ground Systems program. And what my group does particularly is we're the transporter group. Basically anything that's flight hardware that needs to move between facilities at Kennedy, it gets moved by us. And what we're best known for is that behemoth right there. That is the crawler transporter number 2. We have 2 crawlers. That one's number 2. How do you know it's number 2? I have a funny slogan. Brakes are blue. You can see those right there by the disc. If those brakes are blue, you're on crawler 2. So a little bit about the crawler. You know, it's been in use since 1965. It's carried every Saturn V full-size rocket, as well as every space shuttle from the VAB to the launch pads A and B. And now currently, Crawler 2 has been modified to carry the Artemis rockets from the VAB out to launch pad B. So I want to take you through a rough process of the operation. We have an X1 day where we bring the crawler out from the yard and we travel through the S-turns and then come back towards the VAB. You're looking on the left photo, that is the VAB high bay number 3. That is where the mobile launcher and the Artemis 1 were stacked and staged. So the crawler will come in the day before. We'll do all our X1 checks, check our steerings, check of 15 subsystems. We'll do all those different checks, make sure the crawler is ready to support the operation. And then on the day of, we'll roll underneath. In the second photo, the crawler has a leveling system that can adjust the height between 20 and 26 feet. So we'll roll underneath. We'll pick up the assembly, which this is the Artemis rocket with the mobile launch platform and the tower. It's not a light load.
Yeah.
There's only one vehicle that can do it, and you're looking at that. And rolling out, it's not just a crawler crew at this point. This is an integrated operation. We have crews on the ground monitoring moving parts. We have people up on the platforms, pulling platforms back. We have ML subsystems technicians securing their subsystems, and some even riding along on the mobile launcher itself, continuously monitoring. We have purge units getting crawler power, purging the systems, the flight systems that need to be at a certain condition even throughout rolling out. So this is not just a few people. This is a handful of people. And I didn't even mention the LCC. You know, all the engineers involved there monitoring their systems, the launch director, the ground test conductor. So this is a very big involved task. So going to launch pad B, it's about 4.2 miles from the VAB. Short trip on the car, about 8 or 9 hours on the crawler. They call it the crawler for a reason. At the very end start of the pad, you can see that slope is about a 5% grade slope. The crawler's leveling system is specifically designed so that even as the crawler goes on that slope, the platform where the rocket is sitting doesn't see a difference any more than 3 inches from level. So the rocket has a nice smooth ride up there. Nevertheless, that's a very critical part of their operation, and we have all hands on deck, so to speak, monitoring everything that's going on with that. And then once complete, the crawler will roll back down the slope and secure for the day. Full operation, you're talking maybe 22 hours total, so quite a long day. And then this is just a quick video. You might notice that guy with the sunglasses. So I just wanted to show the crawler in motion, what the driver does. Being an engineer, the engineers on the crawler group are the ones who get certified to drive. There is no DMV class. There is no formal training besides what the experienced drivers show you and teach you on the job. This is 100% on the job training. And you can see that the belt assembly moving. The crawler also doesn't use wheels. It uses steel casting shoes, 57 shoes per belt, 8 belts total on the crawler, 456 shoes total. And you can see it's not just the driver, there's people on the ground. There's also a control room with other engineers. GBCT is the head test conductor. There's a jacking, equalization, and leveling operator that keeps the chassis level. The chassis is floating on some hydraulics. And then finally, I wanted to touch on the different people who put their actual hands on these systems. So I mentioned earlier that the Crawler 2 was modified by 50%, total weight capacity from 12 million pounds to 18 million pounds. And how was that done? It was done by dozens of different tradesmen, refurbishing the crawler and strengthening the structure. So on this first 2 larger pictures, you can see a few of the shoes being removed. Shoes are wear items, just like tires in your car. So they're removed and reinstalled with a new set of shoes. And that was done for all 456 shoes. And then that small picture there, that's actually a very critical part. That's a traction roller bearing that's at the very bottom of where those shoes make contact with the ground. And those roller bearings were removed, replaced with much larger, more robust bearings. And that's what actually holds the weight as the crawler makes his moving. And this is just some more work during modification periods. That giant vertical cylinder you see there, that is one of the 16 jacking and equalization leveling cylinders. That's the newer model. It's a little bit wider cylinder made for the expected weights of the Artemis program. And of course, the propulsion is propelled by two 16-cylinder diesel Alco engines, and those are the original engines since installation. It's amazing that those engines are more or less exactly how they were in the 60s, but you don't understand the amount of the effort, maintenance that's done on a day-to-day basis. Even when the crawler's not moving, there are always hands being put on those engines. And finally, just want to highlight the people on the ground. Our technicians laying down plywood as the heavy weights the crawler carries goes through asphalt. We've learned in the past that without some protection, that asphalt will break. So the plywood is put there as a sacrificial layer. And the technicians will wear radios. There's a whole OIS radio system on the crawler to communicate to the crawler engineers and technicians from the ground up to the crawler. And this is just a small sample of the men and women that are a part of our group. This is when we were recognized as the heaviest self-propelled vehicle in the world by Guinness Book of World Records. We like to joke that we're in second place too with Crawler 1, but we'll take number 1 as well. We'll take number 1. So, yep, that's all I had.
Thank you, Dan.
Thank you.
Rebecca?
Hi, I'm Rebecca Tolotovich, the technician lead, mechanical lead for Artemis Crew Module 3 and 4. This is just a few slides of the day-to-day operations that I'm involved in that role. This is Artemis 1, which just launched. This is right before it got stacked on the service module, working on the R&R feet for mating that. And then this is the rocket that Daniel's team took out to the pad. So it's on the mobile launcher there. I got to go up and do some work on it while it was stacked, which was a pretty awesome experience. They needed people that have done the work on the ground to go up on the mobile launcher and do it, and I got to go out there and do that. And this is the inside of Artemis 1. We build the crew module from the pressure vessel when it arrives from Michoud. It's completely empty. It's just the pressure vessel. There's nothing on it. We are responsible for building it up with primary structure, and then we do the secondary structure. We install the hatch, drill the hinges, install all the back shell panels for the thermal protection, all the boxes inside. You can see the dummy astronauts that flew on Artemis 1 are in there, in the seats and everything, the console's in there. We do all that build up in this role. I was part of, our whole team was part of the environmental testing that Artemis 1 went through. They loaded it in the Super Guppy and flew it up to NASA's Glenn Research Facility in Ohio. And this is the unloading from the Guppy, which is also from the 60s. NASA likes to just reuse everything. But that plane is pretty awesome, the technology that it was so advanced, and obviously they're still using it, so it works pretty well. And that's the trailer that they shifted over on from the Guppy to the facility. And that's the stack right before it went into the chamber. That's the facility in Ohio where it went through a bunch of thermal testing, and I think we were there for like 6 months to complete all that. It was more setup than testing almost. They had crews go up for a few months, set up the tests, and then they'd run the tests, and then we'd go back and deconfigure. They'd do another test, we go back, deconfigure, reconfigure, and they did most of their environmental testing in the facility there. I think that's it for me.
Thanks, Rebecca. Jason.
All right. Good afternoon. I'm Jason Dickerson. I work transportation and logistics at Marshall Space Flight Center. So real quick before I get into the slides, just a quick little background. I'm an Auburn University grad, aerospace by schooling. From there, I did ROTC and commissioned as a second lieutenant, and just got stationed just up the road here at Aberdeen Proving Ground, working chemical, biological, radiological, and nuclear defense. It's a whole mouthful, but it's a one little geographically separated branch there, which I didn't think that it would even, ever come into my brain back at NASA again. But after listening to a lot of these presentations and stuff over the last day or so, one thing we've been talking about a lot is radiation exposure while in space on all these trips. So it kind of gave me a little blast from the past, I guess, because I used to work on some radiation detection when I was there. After I got out of the Air Force, I went and worked in operations management at Amazon, so I got to interact a lot with the workers there who really make that delivery engine what it is and the success that it is. From there, then I came back to NASA here, and it's where I'm working on marine operations. So what marine operations means in my office is that boat right there. It's the NASA barge Pegasus. So I don't know how many of y'all know that NASA does have a boat. We used to have a few more. We do have one left. We got rid of the ones from the 60s. But this one was modified back in 2015. It used to carry the external tank for shuttle, and it was lengthened to accommodate Artemis. And so very high level, what we do is we go to a location, we go to point A, we pick up either a flight article or whatever it is that we have to pick up, whether it's a ground support equipment, flight article, non-flight article, and we take it to point B over some body of water. Sometimes that's river, sometimes that's the ocean. In this case, you can see right there, that's the core stage for Artemis 1, and that's it's still in the B2 test stand at Stennis, Mississippi. All right, let's see if I can get these things to work. All right, so I said I work on marine operations side. We do have a ground crew, and at the time, the ground side counterparts were the ones taking that out of the B2 test stand, lowering it down into its ground support equipment you can see there in these cradles. From there, it is just a long process of getting the rocket onto the barge and getting it secured. We secured all these pedestals, and that's, like Dan, it's a pretty long day torquing down all the bolts when we actually go to secure that down. All right, we got here it taking off. This is me on top of the B2 test stand. My boss in this one is actually on the barge, escorting it to Kennedy. And we take it out through the Intercoastal Waterway into right around the Gulfport area in the Gulf of Mississippi, or Gulf of Mexico, right off the coast of Mississippi. So we have 2 river tugs that'll bring us out there, and then we swap off into 1 ocean tug while we make the ocean side of the journey. So you can see here, there's usually a lot of nothing that's happening when we're out in the middle of the Gulf. It's pretty peaceful. You see right here, it's just, as far as you can see, nothing. But it's one of my favorite points on there. So I'm actually on the barge at this one. This is when we were taking the engine section for Core Stage 3 this past December, which was actually kind of funny. It was a little story I was telling earlier that around 11 o'clock at night, I think it's probably actually the same night, I was on the bridge wing right here looking up at the moon. We had a huge full moon. It was super orange at the time. And so sitting there looking up at it, I'm like, man, we're about to actually put people back on the moon. I was like, hold up. The engine section's in the back seat that's going to do that launch. So it was kind of a cool little moment there. So once we actually get to Florida, we start going into Cape Canaveral. We swap off our ocean tug and we get these 2 river tugs again to go up the Banana River. We go through 1 drawbridge and 1 lock to actually get us to the VAB. So start to finish, here's where we have the core stage for Artemis 1. This is when it's halfway off the barge. Wonderful time for them to take that picture. Almost every single one of us on there, we had to pull us away from our roles at the time because we had to actively ballast at this point, so it was a nice little break. But right now, yeah, the core stage is still half on the barge, and it's kind of a weird spot for it to be. And somehow we have, looks like 2 of our ground crew that kind of snuck in their picture last minute. But so that's all the slides I have right now. So real quick, I just wanted to kind of emphasize that's top level, going from point A to point B. I have a couple people ask me, what do we do when we're not moving anything? Well, being the barge that it is, I don't know if whoever owns a boat, but it takes a lot of maintenance. So a lot of times we manage the general maintenance and improvements for the barge that need to happen for the next launch and the next launch. But we also work very closely with our commercial partners to make sure that whatever we're moving next, say for instance it's EUS, that the transporter that they're using, we're using our lessons learned from the past to make sure that it's going to be able to get on the barge seamlessly and actually interface with everything that we have to interface with on the barge. Make sure it's secured and get from point A to point B exactly the same manner. So I think that's all I got for the moment.
All right. Thank you, Jason. So I do have some follow-up questions for all of you. So I'll start with Mark. So you've done quite a bit of different roles. What's been your favorite program or project to work on, and why?
Well, that's a tough one. It's kind of like asking who's your favorite kid, you know? I mean, working on the Artemis program on RS-25, it's amazing, right? I mean, we're writing history as we speak, and it's a great program to be a part of. But if I were to look back at my early days at Aerojet Rocketdyne, when I first got hired on the Space Shuttle main engine team, before that, the only real thing that flew that I ever worked on was a remote control airplane that I built with my dad in the garage. And to be able to be a part of such an iconic program that I grew up going to school and watching shuttle launches and seeing like all the history and all the science that came from the shuttle program, and to know that now I'm the one who's actually getting to work on it, it was life-changing. So I guess my favorite program would have to be the human spaceflight program as a whole.
Yeah, just being part of sending people into space.
Yeah,
that's
it's amazing. Great. It is definitely life-changing. Because I started my career after high school working on car engines and motorcycle engines, and now I'm building the rocket engine that's going to send astronauts to the International Space Station. Are you kidding me? Like, it's an amazing experience, and I was able to be a part of that. So it was very life-changing.
All right. So Dan, I got to go down and see Artemis 1, the SLS rocket, near the pad, and I saw that ramp, and I was like, oh, I didn't know that was such to me, for rocket size, it looked like a really steep ramp. So I'm glad that you included the whole leveling thing. You talked about the pretty big size team that it takes to move an SLS. And I think maybe if you could split it up into like drive day and maybe maintenance day, how many people are on that team, and what kind of skill mix, what are all the different skills that you need?
Sure. So within the crawler team itself, we have about 30 people. I'd say about 2/3 of that are just technicians, and those technicians are mechanics. Some are more specialized diesel mechanics, but we just clump them to mechanics. And we also have electricians and engineers like myself, a manager, and a couple planners. So within our group, it's pretty well knit. We all know each other. We all work together. But for an integrated operation like during the move, it's much more people. We have cranes, doors, platforms. There's got to be somebody that knows how to open that big VAB door, pull up those flips, get all the access points cleared. We have ML, GSE personnel who are up there securing their systems and monitoring. We have ECS, environment control systems, with the purge units, keeping the flight systems in good condition. Rolling out, we got roads and grounds personnel, at police escorts. So there is a wide range of people, and I didn't even mention heavy equipment personnel to support us, riggers, welders, machinists, whenever we need new brackets or changes made. We rely on those technicians a lot.
All right, thanks. So, Rebecca, your very first picture of those green R&R feet, I have a little story. Back on Orion's Exploration Flight Test 1, I was a delegate spacecraft lead, and I was on the floor when we were moving the crew module, picking up the crew module and putting it up to someplace else. We didn't have those feet yet, and we had ground support equipment, and it was a lot more tricky than I imagined just to pick up the crew module and move it. So I think the lessons that we learned on EFT1 resulted in those feet. But what I wanted to ask you about is, so how did you find your way to this job, to working on Orion, doing these amazing things?
It was honestly kind of accidental. I did not grow up on the Space Coast like most people that I work with did. I grew up in Maine, very far away from the Space Coast. There was essentially no space presence there at all. I, kind of like Mark, I didn't really know what I wanted to do after high school. I had a plan that got derailed, and I had no clue what I wanted to do. So I did automotive for a year because I liked working with my hands and just being involved like that. So I did automotive technology for a year at a vocational school, and I really wanted to move out of Maine. I just realized I loved it there, but there wasn't many opportunities. So my uncle, who lived in Florida, saw an advertisement on TV for the aerospace technology program at Eastern Florida State College, and he said, it's kind of the same thing. And I was like, okay. And I moved down, and I enrolled in the program, and I realized how little I knew about aerospace. I actually tried to do I was doing an essay for some task that we had to do there, and I was trying to do it on the backup landing facilities for the shuttle, because one of them was Bangor, Maine, which was kind of relevant to me, and I couldn't figure out why everything was past tense. And it's because the shuttle program was not going on anymore. And I didn't even realize that, because it's just not something that is relevant back home. So that just kind of shows how little I knew about what I was getting into. But eventually I graduated from that. I got an internship with Lockheed at the ONC and got hired on full time. And I'm technician lead now. I've been there since 2017, so I've been part of the Artemis 1 buildup, and I've been part of 2, and we're on 3 and 4 now. So never would have pictured myself there, but it was a great opportunity, and I'm glad I took it.
What do you think is more difficult, the automotive industry or what you're doing right now?
I think it's very different. There are similarities as far as the technical background, definitely very beneficial. But I think that it's a different kind of difficulty in the aerospace industry because everything is new. You're not building a car for the 300th time. No one's done this before. It's even different than SpaceX. We're not going to low Earth orbit. We're going to deep space. No one's done this before. It's not a production type facility. Everything, even though they want to get into production, it won't even ever be like airplanes. It's just a different challenge. I don't think you can say which is more difficult.
Great, thank you. So, Jason, when you have SLS on your boat and you're in open water, in public waters, and it's basically such an important part of the space program, what are the things that maybe the audience wouldn't think about that you have to consider about safely transporting a piece of hardware like that?
Sure. There's a lot of components to that. There's a lot of answers to that question. One, I kind of want to say that one of the biggest important things that we have to worry about is the barge safety itself. I mentioned earlier, we have one barge. We used to have more, but we just have the one. So if anything happens to the barge itself, then core stage doesn't get to Florida, and we have to go somewhere else because that's the only way it's getting there right now. It's not going by rail. It's not going by truck. That's our only options there. So really we have to make sure that the barge stays intact. Everything else, so other parts of the year when we're not doing these operations, we're working very closely with our commercial partners to make sure that, stress is involved. All the studies have been done to make sure that, regardless of what happens while we're underway, that the article is going to get from point A to point B safely. So we're really not worried too much about that. Well, no, I can't say that. Yeah, we're very worried about that. So we make sure we take the precautions to do so. But the biggest, I would say, challenge that we have is weather. So you saw in one of my pictures how dense the fog was when we were going from the Intercoastal Waterway to the Gulf. And that was on for the engine section for Core Stage 3. And we actually almost had to wait another, 6, 7, 8 hours right there in holding, because we had to make sure that our guys can see what they're doing when they're switching out between our tugs to get to the ocean tug. And that's a kind of a little bit of a process, a delicate process. So really weather is probably one of our biggest ones. When we were moving down the Atlas V rocket for ULA last year, that was a kind of an impromptu thing that we had to do. It's not something that we typically did. It was the first time NASA had ever moved a commercial rocket, so that was kind of a cool deal. But we had some challenges because we couldn't actually get to that, where we couldn't get to ULA in Decatur, Alabama. We had the Wilson lock was closed. We couldn't actually get there, and we couldn't take the alternate route to get there. So we had to get the Atlas V rocket on another uncovered barge, get it to another spot in Mississippi that we could get to, and even that was a little sketchy because it was right about to go into summer pool and the water was a little bit shallow, so we didn't have that much water beneath us, and we're like, hey, we did our due diligence, we went out and did site visits a few times to make sure that we're not going to get stuck there. So that was a kind of an interesting challenge, but we got to do that, and it took a decent amount of time to get that ULA rocket all the way to Florida, just due to weather. Sometimes there was fog, you had to pull over to the side because you can't see on the Mississippi, and there's a lot of traffic on the Mississippi. By the time it gets to the Gulf, we had storms there too. We had to hug the coast a little bit and make sure that we're avoiding storms and making sure everything is safe. So I'd have to say that weather's probably one of our biggest challenges on that.
All right.
Could I add to Jason too? Because
Yeah.
I think we talked a little earlier, and we have a lot of similarities between we both transporting flight hardware. So the crawler too, weather is a concern. You obviously don't want to travel with a full stack with gusts to a certain speed. So there is a forecast. Usually it's a 48-hour forecast, and the risk of inclement weather is, they give you a percentage because, it's really just educated guessing. No one can really predict the weather. And a little bit mentioned on the different obstacles that have come up. That pad slope, one time we were going up to pick up the rocket, and that the gel system has some tolerances where its maximum delta can be from the lowest end to the highest end. And we noticed there was a few low spots on the crawlerway itself, which caused the gel to compensate for that, and it actually passed our boundary level. I was sitting on the gel myself, so what a great time, right? And it actually hit the red, the marker hit red, which it had never done before while I was sitting on there. So obviously you don't want to pick up a rocket, go down on the most critical part and realize your leveling system can't compensate because your road is just not even. So what we did, we actually went down, we called the roads and grounds crew it's responsible for grading that part of the pad, and they graded it once again. We went up, and lo and behold, it still was out of tolerance. So we did it a few more times, and actually got to a point where we had to get a survey done on that slope. Once the survey was done, we went up, and I don't know, fifth time was the charm. We got it within that tolerances, but then that opened up the I guess assumption that the grading done on the slope was fine. What turned out is the person who had done the grading was a 30-year veteran. He had been doing it his whole life. He didn't need it. He didn't need a survey done because he just knew it like that road like the back of his hand. And someone had taken over who was more green, didn't have that experience. So now, to prevent that in the future, we're now working with we're trying to get better equipment with surveyors. We're trying to get those drawings that outline the percent grade on the slope to within a specific tolerance and a test beforehand. So we're just finding gaps in information that we're
It's
trying to
funny
fill.
that you talk about gaps, because in the manufacturing world, we call that tribal knowledge. And there's a lot of cases where we have a workforce and that has performed this job, just like what you were saying, that they perform the job so many times. They know it like the back of their hand, and all of a sudden they retire.
Yep.
And the next generation, the people who are going to pick up, where they left off, are clueless, and now we have to relearn everything, and that brings us back to the importance of keeping up the pipeline of skilled workers in our industry, because we have an aging workforce, and they're moving on, from this life to the next sometimes, and we need to make sure that we fill in those gaps, like you were saying, because or else we're going to be left in the dust, and it's super important.
Yeah, I see that issue there. And Rebecca, you mentioned coming from Maine, you didn't even think about the space program. So, and this is a question kind of for the group. Given what you're seeing, given the need to build that skilled workforce, and it sounds like we don't have enough folks. What are your thoughts about how to draw folks in and get them trained and pass on the tribal knowledge?
I could start if you want. So I think we need to touch on two things. The first thing is we need to inspire people, right? And we start that with STEM-related courses at a young age. We need to educate people not only about STEM-related courses, but that there is a spot for you in this industry. And you don't necessarily have to be a scientist or an engineer. If you're a mechanic or a 19-year-old kid who likes to work on their car in the garage, there's a spot for you, right? So we need to go out and educate people that there is a place for you in our industry. The second thing is that we need to educate people who are already in the industry. People who are working in the garages, who are working in the other shipping fields. Like, hey, we do this in the space industry. You don't have to just do shipping containers. You can actually ship rockets. We need to educate people and motivate people and bring them in, and not just rely on the traditional ways of getting skilled tradespeople. We need to start venturing out into other pools of talent, and not just be narrow-minded on our traditional ways.
Yeah, I agree on that. It's really making some of these positions known that they exist. It is possible. So, like, one good example on my side of it is that we have a good majority of our crew that's on the barge. I mean, well, there's not that many people on the barge, but the crew that we do have on the barge, a majority of them have come from offshore work. They all worked on the oil rigs offshore, and so now they're our crewmen, right? So even before I got to NASA, I didn't know we had a barge. Like, I didn't know we had a marine operations side at all. I'm willing to bet until they saw a job posting one time randomly, they didn't know that there was an option for them to go from an oil rig to the barge and move rockets. So it's just getting some of these positions known that no matter where you, like at Kennedy, I mean, you can have pretty much any trade, whether you're an electrician, a plumber, or like anything, and you have a spot somewhere that you fit into the puzzle somewhere. And I think that's a big part of what we've seen here just the past couple of days is how many different people are involved in these endeavors to get to the moon, to get to Mars, that it's, some things I didn't think that existed. It's kind of mind-blowing how many people are involved in all these endeavors.
I want to add to that too. So I went the traditional route. I went to school, got my degree, and I'll just say I probably had the least hands-on experience of any of these three of this panel when I started the job. And working on the crawler, on the subsystems, and learning those systems just built that confidence in me to do other things with my hands. Work on the car, work on the house. So it really is very powerful to have that, and it just I feel like it just makes you a better, more capable person generally. But growing up, they never said trades might be for you, vocational skills might be for you. It was always embedded. Go to college. That's the right way. You're going to be successful if you go to college. And for some people, that's correct. But for other people who don't do the proper research, or who might not be the best educated in high school and be best set up, that some people just it's not the right route for them. And I wish even the classes that I took in high school, like I didn't have shop class. I didn't have any hands-on type of classes. I know that's kind of a different subject, but
I think it's directly related.
Yeah.
Because there's been a huge decline in shop classes in high school, and again, like you said, the traditional path is college.
Yeah.
What about shop class? What about woodworking, metalworking, welding, automotive mechanics? Like those are all important skills that for the past couple decades have kind of slipped by and
Some people see
almost
below
looked
these.
down upon.
Yep.
Like, oh, you're just a mechanic. Well, okay. Well, I have a degree in something. Okay, good for you. But I'm a mechanic on spatial engines. So I think I'm kind of cool.
And one more thing to add, I actually talked to my director about this, about hiring different trades, and he said the need for trades, there's a need for every trade right now. But if you were to pinpoint it specifically, specialized electrical, mechanical techs, similar to what these guys all do, a lot of that, you got to come in with the basic knowledge or the journeyman license, and you learn it on the job, just like what I did on the crawler. So, but regardless, if you learn those specialized skills, there's a job for you out there in the space program, and the program is only getting bigger as we move on. We have private companies too, and NASA is planning future Artemis missions. So there is a lot of job security there for anyone who wants it. And I wanted to mention this sooner, but launching rockets also requires more than just rocket scientists.
Another point to add to that is, in my field directly, just in my shop, most of the time the best engineers are the ones that started out on the floor. So you don't necessarily, if ultimately you want to be an engineer, there's paths to that even without just going to college immediately out of high school. Most of the good techs that are in my shop, they just have that mechanical background. They don't necessarily have, none of us really have a degree. And a lot of them have A&P licenses, which is another industry that is specific, but it translates very well to the aerospace industry. And then moving on up to engineering, when you have that background and you worked on the floor and you know how to interact with the actual workforce on the floor, that translates so well to being able to move up and integrate and be successful as a team to interact with the people that are actually hands-on when you've been there before.
And I would expect that that flow of knowledge and the relationships that are formed will allow us to design. We're going to need to design some very difficult vehicles to go land on Mars, and we have to be able to produce them and produce them on a schedule and produce them without any mistakes there. And that's a really tall order. And maybe, Rebecca, I'll ask you first, but then open up to the group. The on-the-job training, the tribal knowledge passage, how is that happening on the ONC floor right now?
That is, I'm sure it's common in every company, because you mentioned it also, but it is something that we run into a lot, and that workforce is aging, so it's bringing these newer engineers that are writing the work instructions to getting them on the floor. So when they're on the floor in the shop and we run into an issue that we've run into 1,000,000 times but no one's ever changed it in the work instructions, everybody's done it before, so we just do it the way we know it's supposed to be done. Then you get these newer engineers, when you include them on the floor, then they can include it in the work instructions so that the next time when somebody's retired or somebody's on travel and hasn't done it before, it can be done the correct way because it's actually written the correct way. So there's a lot of gap between the tribal knowledge of the technician workforce, between the older techs and the newer techs, but then also just the technicians and the newer engineering. There's also a tribal knowledge gap there, and a lot of times work instructions are written per best shop practice. That has to be defined at some point because your
On
best shop
best effort
practice is a lot
basis.
different possibly than my best shop practice. And maybe there's only one best shop practice that is the best. So it should be specified. And that's that tribal knowledge gap that we sometimes lose out on. And it's known, but in the ONC anyway, we're working on it. And in the years that I've been there, it's come a long way, definitely. It's improved, but it's something that will definitely continue to need improvement.
I would expect that younger engineers who get pulled onto the floor might be a little more open to changing those work instructions than if they haven't been writing them the same way for 30 years.
Yes, it's difficult to argue with someone who's written it and since the beginning.
Right.
It's easy to tell someone when they come up to you and say, I'm writing work instructions for this. I don't know what this part is. Where is it? And then you can go show them and tell them why we should do it a certain way. It is a lot easier to deal with that.
Yeah, and we have something similar in our group, proceed per engineering direction. So, I get what you're saying with the gap in the tribal knowledge there. Also, we're working with different generations too, you know, with the Gen X generation and the greatest generation World War II era, baby boomer era. And they like to hold very tightly their knowledge, and it's very hard to change nothing. Just keep it the way it is. Old dog, new tricks, no way. But like younger people that are coming into the workforce, they need to learn these things. Why things are done a certain way? Because there's going to come a time where that older person retires or passes away, and if that knowledge will be lost without it. And so from my point of view, I feel like if you truly love your system, it's been your life's work, why wouldn't you want to recreate yourself into a younger technician or a younger engineer, and so they can continue that great work and then teach the next younger generation. But it's a two-way street. The younger generation, I know all the things that's said about them, self-entitled, arrogant, they know it all, so you gotta meet in the middle. You gotta be respectful, you gotta be patient, you gotta be considerate. Now understand, they got the system to a certain point. So the older person too, if I've noticed personally, just in my general life, the nicer you are to somebody, the more likely they're willing to, share their knowledge with you. So,
And one thing we're doing at Aerojet Rocketdyne is, and we see and we notice the problem of the tribal knowledge gap. One thing that we're doing is, let me ask you guys, what do you do when you want to learn how to install a lighting fixture?
YouTube.
So one thing we're actually doing at Aerojet Rocketdyne is we're implementing video planning, and we're actually going out to the floor and getting with our technicians and recording how they perform their work, because there's only so much that you can record on text, through text. And we're living in an age where it's easy for anyone to just pick up their device and press play. So we're actually using video-based planning where we can always have that knowledge to come back to. So even when our technicians decide to move to another department, or if they decide to retire, they can always revert back to that planning instruction and press play and see how the best, most efficient way is done. And it also gives a chance for newer employees and newer technicians to critique it. If they watch that video, they can also say, why are we doing it like that? Why can't we do it like this. And it makes our jobs a whole lot easier when we're updating these work instructions. So there's definitely things that we're doing to mitigate the problem of the knowledge gap, but it still doesn't take care of the major issue of filling in those spaces when other employees decide to move on.
Okay. So at this point, I'd like to open it up for audience questions. Looks like there's 2 microphones in the back of the room, so don't be shy. Looks like.
Do I have to use the mic?
Well, we can repeat it for you, but.
Well, I mean, I'm loud, so you can hear me.
There's a mic up here too, if you want to use it.
I'll go this one, I think. Are we recording these?
Yes, we are.
Oh,
Yeah.
good. I was gonna say, number one, I wanna show this to a couple people over here, who are looking at this as, it's a major focus of the administration right now, everything you guys have been talking about. And I wanna capture this and take it to some meetings and show some people, because I think it's great, everything you've been saying. My second question though is, and I wanna touch on something you brought up, Mark. The whole idea of inspiring, you know, you're absolutely right. We got to make the jobs, make people aware. But like for the people, for instance, that are working out in industry already, why should they want to switch to the space industry? You know, maybe our pay scales might be a little better, maybe not. But to have the chance to say you're working on something that's going to send people to Mars, that's maybe why they might want to make that jump. And so I was just going to bring up with you and throw it out for your, consideration. I know like some of our engine parts get made in my hometown of Indianapolis, Indiana. And Mary over here always drags me out to go talk at some of these outreach activities. So I got the chance to go to the shop there at Major Tool and talk to those guys. And I could not believe how much it meant to them to be working on parts that go into those engines.
Absolutely, yeah.
And so, just could you guys all maybe comment on how could we do that better? What are things that you think we should be doing to go reach out to those suppliers that we work with, or those folks working in adjacent industries like at Amazon or on the oil rigs? Or how can we go to Maine and get people in Maine that, maybe haven't heard about what's going on with Artemis? So throw it out as that's my question.
Okay. All right. So I don't know how many of y'all caught Mr. Bruno yesterday, the CEO of ULA, when he was talking about that. And he said one of the biggest things that's going to not only get us to getting to Mars, but what's going to keep us there, it's not going to be necessarily a like a space race type thing, but there has to be something tangible for us there to really work with. And he was talking about cislunar resources and how to actually utilize those and make an industry off of that. And I think a lot of those are going to mirror some of the industries that we have right here that people do those jobs day to day right now. And I think it needs to be kind of a push to really advertise in the future to these people, like, hey, if this is the kind of roles and stuff that you're interested in, I mean, it may not be them, it may not be their kids, it may not be their grandkids, however this falls out, but start to really focus and channel that into, eventually our goal is to have not just 1 or 2 people on Mars, not just 1 or 2 people on the moon, but really an actual civilization there, right? And so if that's something that interests you, and to be literally a pioneer, kind of like what happened, back when people started crossing the oceans, this is a really exciting thing. You get to be a part of that you're going to start building space societies, and you can do those same jobs out in space.
So, yeah, the inspiring is very important, and like you said, that there are people out there doing the jobs, similar jobs, but not in the same industry, right? And I'm pretty sure you guys can relate that, we chose this path, or we're here now, and we are doing something big. We're doing something like that's huge for humanity. Some people join the military. Some people, practice medicine, but here we are involved in the human spaceflight program. But like you said, there are other people who are going to ask why. Why should I leave my job working in the automotive industry? Well, I think, was it earlier today or yesterday? Oh, yesterday, I saw an image on the big screen of a JAXA rover with Toyota on it. I was like, oh man, it's like the the new Tacoma for the moon or something, you know, like, and it connected with me. And today I heard that there's a company, Leidos, that they're developing a lunar rover with NASCAR. Now you're finding a way into people's homes. Now you're finding a way to connect with them and get them excited about, like I'm not a big space nerd, but I do love off-roading. And you're telling me I can work on stuff like this? Where do I sign up? You know, like, I'm a big NASCAR fan. And that you're telling me I can work on stuff like this? Where do I sign up? We need to get people excited through all facets, all different pools of the industries, of different industries. Because, like you said, there's going to be people who are going to asking, why should I leave what I'm doing now? And if we can get those connections going, and spark up the excitement for wanting to join the space industry, I think we're going to be a whole lot better place than where we are now.
Absolutely.
Yeah, I think that word of mouth, the relationships that we all have, and how it spider webs out from Maine to California to Hawaii, right? Okay, question in the back.
Hey, good afternoon. My name is Bruce Powers. I'm a test engineer for the Department of the Navy. So I deal with nuclear submarines, ballistic, and attack. And I'm going to ask you, that's my brief background, I'm going to ask you a tough question, and you're going to do great. But let me give you the background on why I'm asking the question in the first place. So I used to fly around in Navy aircraft as a naval flight officer in P3 Orions chasing submarines under the ocean. That's another life. Whenever I landed, I had technicians and maintainers come on board my aircraft and say, Lieutenant, you broke my aircraft again. You need to tweak this, you need to, you're using unauthorized tool. You, Lieutenant, are an unauthorized tool. So, you need to not touch this. You need to, just stick to this. But, we will fix it for you. Okay. So I was always worried about, well, okay, is this fixable by me or not? Okay. The second is, in the military, we actually use something now called interactive electronic training manuals, which are akin to your YouTube idea, mainly because we have massive amounts of turnover in the military every year. You're only there for so long, and then they're gone. And it's like, well, how do you train the new people? So there's a continuity of people, but there needs to be a dynamic, easily changeable method of training people that, will stick around and is not paper-based. Okay. So here's my tough question. So you, as tradesmen and mechanics that are very knowledgeable with this tribal knowledge of how all these aerospace systems work, you've been called to a panel of how to design the next Mars habitation, system, okay, and lander, all right? What are your top 3 things you're going to tell whoever is designing this, either a commercial company or hopefully a public-private partnership with NASA? What are the top 3 things that you're going to tell them? And I'll start you out with one, and that's the idea of maintainability, okay? How are we going to fix this stuff? Presumably, smart engineers have already made it highly reliable, okay? So comment on number 1, maintainability. But what are the other 2 things you're going to tell them?
I'm going to make all of you answer that one. So.
All of us answer that.
Well, okay, so I guess I'll go first. Be the first in the lines then. So I think it's also important to know how well that system can be understood. So a certain level of simplicity of the system would need to be one of the factors you would consider. If it's too complicated, if it's beyond the realm of the average person understanding, then that I believe that would cause what we're talking about here. It's hard to train new people, and then you got that same issue with the tribal mentality. It's so complicated, but this guy spent 2,000 hours figuring it out, and now he knows it perfect. He's gone. So I think a certain level of simplicity of what you're designing and how you can implement it is that other point. And let's see, the third point. So maintainability is good. I was going to say that. He didn't say maintainability. How about how well that system can sustain itself? If it's maintained, that's fine. It's got to be durable too. It's something we deal with a lot of times on the crawler, at the pad. We have a lot of great looking systems. It works well on paper. It's easily understood. But if it's not ready for the environment that it's in, or even the users using it, then it's just set up to fail. So those would be my 2 points.
Yeah, I think user interface, how the user is going to be, interacting with the project, and producibility. How easy is it for us to build the parts and to build the hardware that's going to be, coming together? We need to make sure that it's even feasible, and if it's feasible, make it repeatable, and those are all in your basic engineering textbooks, right? But yeah.
If you don't have that connection to where your product's being used, and you're not talking, ideally daily, but often, then it's just words on paper, right?
I think accessibility is another one. A lot of times we see design engineers that are completely separate. They're in a different state. They've never made it to the floor, and it's a line on the floor. It works on CAD, because they drag their bolt over to the spot where it goes. I have to get a wrench on it.
Yeah.
And no one ever thinks about that. Or I have to fit there, and I'm smaller than everyone else in my shop. So if I have a hard time, which happens a lot, like I get delegated to do things because they didn't design it to be constructed. They just saw that it fit. So I think that's a big one, and thinking ahead to integration. Nothing's going to be by itself. So a lot of issues are, even just on my program, on the crew module we do something one way, and on a service module we do it differently. Why? It overcomplicates things, and it brings more opportunity for mistakes. If one shop has a good way of doing something, then it is the best shop practice, and it needs to be implemented across the program, not just this is how I do it, this is how you do it. And that goes across not just the actual work, but the engineering part of it as well. If we write work instructions a certain way on the crew module, it needs to be written the same way on the service module, because it works, and it needs to be consistent.
Yeah, absolutely. The interface on that one, that's an absolute big one. It's making sure you're talking to all the right people when you're designing and building these things. So like, there's a few times, like I mentioned before, when we're bringing in a new article onto the barge, and we're looking at their transport. So that's why we're involved in those meetings to ensure that, hey, we like your design, it looks great, and it'll move you to the barge, but we can't set it down anywhere, because we can't get wrenches there, because there's stuff blocking its way, because we're familiar with this. So making sure that it's interoperable with other pieces of equipment too, and getting everybody involved that way, it's super important.
All right, those were some great answers.
All right, so I've got 2 questions. First one's a simple, easy one, but you talked about it being a slope. I think it's more of a hill when I look at it from Launchpad. So do you have to be more experienced to drive that slope, as you call it, or a hill, as I would call it?
Yeah, that's actually a good point. So the senior engineers, they kind of have a rough training procedure for drivers. You first start on the straightaway, then you learn the first turn, then you learn a tougher turn, but then you go up the hill. That's part of the certification process, because what's the point of being a driver if you haven't done every single possibility out there? So I believe the first time up the hill you do it unloaded, because the tolerances on that crawlerway road gets much smaller. You're within a foot to a foot and a half on either side, so there is a a familiarity you got to have. So it won't just be, hey, it's your first day on the crawler group, let's go up this hill, you know? No, it's not like that. For me, my experience, I was about 2 years in with a good amount of training already. I forget how many hours, but I had done several different, I guess, sections of the crawler way up the hill, and then down the hill, with a stack is also another thing. You know, up the hill is one way, down the hill is the other way. But the best part of that is that the driver's seat, there's a backup driver. There's a more experienced person that guides you along the way through the process, so you're not just by yourself.
That's good to know, you know, because I looked at it and I thought, wow, that looks really steep.
Trust me, there's plenty of eyes on you, so if you mess up, you'll know.
Good. Well, so my second question is, in 2 weeks, I'm going to a middle school with NASA to inspire some kids. And so my question to you and each of the panelists is, what advice do you wish you had known sooner in your career path, especially, you know, these middle school, high school students? What should they be thinking about now that maybe somebody's not telling them they should be thinking about?
That there are hundreds of different jobs that you can do to be a part of this, to be a part of the aerospace industry. That you can be a painter, you can be an electrician, a plumber, a machinist, a welder, a doctor, an artist, that there's a spot for you, you know? So I think maybe images of people that they can relate to, that show them that, like, look what this person is doing. This person's working on a rocket and they're doing the job, and that could be you. And this is the kind of stuff that they do outside. They like working on cars or motorcycles, or something that they can relate to and connect with at home is I think a big part of inspiring and educating people of what their potential is for a career path.
Yeah, so I can echo on that one. When I was in high school, so I grew up in Louisiana, a little right in the center of it, in Alexandria, not a whole lot around that area. Basically, when in my high school, if you were graduating high school, you either went a nurse or you went offshore. Like, those were your typical options. That's what everybody did. And so I would tell you, there's just a lot of paths to get here, though. There really is, and almost none of them are going to be linear. Like, everybody's going to bounce around and do all kinds of things, and that's always going to be a good thing. Like, some of the guys that are on our barge, they were an engineer not just on our barge, but on other places, and that gives them a whole wealth of experience, that a different perspective of looking at things when they get there. So they're really versatile at their job. So they know their job, but they don't know how to just do their job in their job setting. They know how to do it everywhere. So I think that's a really cool thing, because I know for me, my resume looks ridiculous. It bounces all over the place. It goes radiation detection, it goes biosurveillance labs in a few places, then it goes to CBurn equipment in Connex boxes, fueling those out to people. Then it goes Amazon, and I even bartended some in between there. So there's a lot of things you can do, and you can always wiggle your way back into something that's in space related.
All right, we are starting to run out of. Oh, go ahead.
So I would say, especially as a younger kid, especially middle school, just keep your mind open to new experiences, because you really don't know what you like until you try those things. But me growing up, I was pretty introverted, I guess, and it wasn't until I got older until I allowed myself to experience those new things. So as a middle school, just try new things and see what you really love. And then as you get older to high school, something I lucked out because I chose engineering, but some other degrees don't have that same return on investment. As you go to school for 4 years, and most students will likely take up some kind of debt. I would also weigh the financial side of things too before you set your sights on, I want to go to Harvard to be an arts major. That might not be the best option. So.
Great, thanks. So we are starting to get to the end of time. What I was going to say is, for the three people who were standing, let's I was going to hit those questions quick, so go ahead.
Okay, mine will be fast. Okay, first, Dan, I'm going to call you out because I'm Gen X. And a big part of my growing up is that everything changed, man. We started with Atari, and now we've got iPhones. So a big part of my career has been outreach and encouraging others and sharing my passion and my knowledge. So by no means gatekeeping. I've actually worked with outreach, so I'm going to say we're the exception to that. But quick question for you guys. You mentioned that some of the most in-demand fields were mechanical and tech and shop. What do you see as we're building a human presence on Mars with these technical fields? What do you think will be the next in-demand fields that we're going to be seeing an ask for vocational and technical?
I'll take it because she called me out again. First of all, I guess we'll just ally against the baby boomers because, they're the true gatekeepers. Yeah. So I would think whatever trade you're in, having some kind of knowledge on computer skills is going to become more and more necessary. So that's the first part. The different trades. Yeah, I don't see how an electrician or a mechanic would go out of fashion anytime soon. Especially if once we land on Mars, once we build those systems, we're gonna need people to upkeep those systems. So, again, I'm biased towards the electricians, but I'd say electrician and mechanic with specialization with computer skills.
I think definitely additive manufacturing. That is the future of manufacturing on this world and on any other world. We just finished a workshop about an hour ago where we learned about 3D printing habitats on the lunar surface and on Mars. We're gonna need operators and programmers and technicians to operate these machines that are going to be building rocket engine components and habitats. Definitely additive manufacturing is where I see a huge need in the not so distant future, aka now.
I can kind of touch on that real quick if I can. So we're doing a lot of things that haven't been done before. We're thinking about how things are going to be on the moon and on Mars. And as of right now, I mean, it's still really just an idea. And so we're talking about having people like electricians and plumbers and stuff. But when we're actually going to start building those things, you're probably going to have a lot of people that's going to be more, I don't want to call them jack of all trades, but we're going to have a lot of different specialties. So it might be, really kind of complex hybrid type tradesmen that go in there. They can really do a lot of things because, as we talked about before, resources are limited, space is limited, and by the time you bring these people, you're going to have very knowledgeable people. So when we're talking about, tradesmen, they're going to really be, at least at first, definitely the best of the best, and they're going to know how to do quite a lot of things, and not just engines, not just electricity, not just plumbing. Really good.
Rebecca, thoughts?
I know we deal a lot with on the manufacturing side of it. They're trying to bring in working with augmented reality, and that's kind of something that you think about video games and all that, but it does translate into this field. We deal with it, and it's helpful, and I see it being an even bigger part of the manufacturing process. Maybe not necessarily the future on Mars, but as far as getting there, I see that being a big part of manufacturing.
All right. Any last minute questions? Okay. Well, I really want to thank all of you for telling your stories today. It's been great to moderate this panel and to listen and hear what we need to do, who we need to inspire. And I think that the message that I'm hearing, I'm kind of close with this, is that, boy, if we're going to go to Mars, we need everyone. And we need to start planning now on how we increase our industry's ability to reach everyone and grow so we can get to Mars. So thank you, everyone. Thank the panel.